Over time I've realized that theory development, it's going to take a lot of time. It's like growing a tree, you know, even though you have the seed and all the right ingredients to make something great, you have to plant the seed into the ground and wait for long periods of time. And that's what I'm realizing. You can't just expect to plant a seed and then all of a sudden it's this giant oak tree that is beautiful and magnificent. It takes time for something like this to take place. Sure, the discovery I made from my own perspective was in September of 2011. So it's coming up in September of 2015, so about 4 years, and it still feels as if it's still a baby theory. So it's still a sapling tree. It isn't anywhere near as large as it's gonna grow. But one thing I wanted to do, instead of these car talks, because I know people were complaining that I'm just talking in my car and I'm not doing any real experimentation, I figure I'd, use my creativity and see if I can't do some experiments and film them onto this YouTube channel. I'm not going to do the experiment in the car, but I'll show you what I'm going to use. Because the accretion model, they want you to believe that somehow when in outer space two pieces of metal slam into each other, they accrete and they make a bigger piece of metal. So, and the velocities that those two pieces of metal are pretty damn high. Maybe around 30,000 meters a second, or 90,000 feet per second, somewhere around there. They're traveling pretty fast. So when these things slam together, they should be able to, clump. So what I'm gonna do is I'm not gonna go that fast, because that would take an electromagnetic rail gun. I can't go that fast, okay? I can only do low velocity impacts. Very, very low velocity, only maybe around 1,200 feet per second. And what I have here is that same copper bus bar that I used for an earlier experiment to show how the entire gravitational pull of the earth couldn't clump these two things together. They just bounce right off each other. I consider that to be an extremely low velocity experiment, and that couldn't even clump these damn things together. So I'd say that's about maybe a quarter inch thick. I don't know, let me get something to measure it against. How about a 45 round? Alright, there's a 45 round right there. That's about how thick it is right there. And so what I'm gonna do, take my old trusty steed. I'm gonna make a cool ass experiment with it. But hopefully we'll see if this little 45 round can clump together to this copper bus bar as per the nebular hypothesis. I think it's a bit better than a math experiment, or a math equation I should say, because there's no such thing as a math experiment, in case you didn't know. And I'm gonna go ahead and see if my buddies can arrange for me to go out to his range. And I got my M16 in the back of my car too, and I will do some experimentation in accretion. We will call the videos "Will It Accrete?" and we'll see what kind of materials can accrete together with a low velocity projectiles. And some other material I have some granite slabs I can use that got discarded from making kitchens and things like that. I have some concrete blocks. We can see if those accrete very well, and those will simulate the chondritic material. The chondritic material meaning rocky / metal material, or mostly rocky material. We'll see if the matter accretes at very low velocities provided by my handgun, my 45, and the 5.56 NATO rounds I have inside my magazines, which are not inside the weapon itself at the time. But yeah, it should be a lot of fun, and I hope you guys get a blast out of it as well. I know how to use these weapons, and before I get, shooting him, I go over a few safety rules to make sure we all stay safe during this. And we wear some eye protection and ear protection and that kind of good stuff. But today is August 20th, 2015. Later.